let me ask you something that almost everyone has wondered at least once. If water conducts electricity, and power lines carry huge amounts of electricity, then why don't power lines spark, explode, or short circuit every time it rains? Think about it. Rain is everywhere. Power lines are everywhere. They cross cities, villages, fields, and highways. Yet, during heavy rainstorms, nothing dramatic happens. No constant sparks, no citywide blackouts, no electric chaos in the sky. So what's stopping all that electricity from escaping? The answer is not luck. It's not magic. It's design, physics, and a few clever tricks most people never notice. Once you understand it, rain will never look the same again. First, we need to clear up a common myth. People often say, water conducts electricity. But that's not fully true. Pure water is actually a poor conductor. What really conducts electricity are salts, minerals, impurities dissolved in water. Rainwater starts out fairly pure when it falls from the sky. So rain alone isn't as dangerous electrically as people imagine. But still, rain isn't perfectly pure. So why don't power lines spark anyway? That's where the real design comes in. Electricity doesn't just jump wherever it wants. It always looks for the easiest path, the shortest path, the least resistance. Power lines are designed so that electricity prefers to stay inside the wire. Jumping into the air or rain would require much more energy. Air, even humid air, is actually a very good insulator. For a spark to happen, voltage must be extremely high, or the gap must be very small. Normal rain doesn't create the right conditions for sparks. So electricity stays where it's supposed to be, inside the wire. Now look closely at power poles. You'll notice strange objects between the wires and the poles. Ceramic discs, glass shapes, polymer insulators. These parts do something critical. They prevent electricity from flowing into the pole, stop current from traveling down into the ground, keep the system electrically separated. Even when these insulators get wet, their shape makes water drip off, not form a continuous path. No continuous path equals no current flow. This is not accidental. It's carefully engineered. For electricity to cause a short circuit, it needs a complete path from high voltage to low voltage or ground. Rain usually falls as separate droplets, thin films that break easily. That means rain almost never creates a solid electrical bridge between two power lines or a power line and the ground. Without that bridge, electricity has nowhere to go. So instead of escaping, it keeps flowing forward, exactly as planned. You might be thinking, okay, but what about storms, wind, or extreme weather? Good question. Problems can happen, but not because of rain alone. Power failures usually come from trees falling on lines, strong wind pushing wires together, broken insulators, lightning strikes. Rain by itself is rarely the cause. In fact, modern power systems are designed assuming rain will happen, a lot. Rain is expected, not a threat. Even though power lines don't spark in rain, that doesn't mean electricity becomes safe. Downed power lines are extremely dangerous because they may touch the ground. They may energize puddles or metal objects. So the rule is simple. If a power line is damaged, stay far away. The system is safe when intact, not when broken. So why don't power lines spark in the rain? Because rainwater isn't a great conductor. Electricity prefers staying in metal. Air resists electrical flow. Insulators block escape paths. And systems are built for wet conditions. This is one of those moments where you realize what looks dangerous is actually carefully controlled engineering. The world around us isn't just working by chance. It's working because thousands of small design decisions are quietly doing their job even in the rain. Next time you hear a storm outside and see power lines standing calmly overhead, remember, they're not ignoring the rain, they're designed for it.